Hi, I'm Dr. Russ Leftwich. For the next 20 minutes, I'm going to tell you the story of FHIR and how it was created as a healthcare data standard for the future. I'm going to start by going back to the 1980s when interoperability in healthcare really started. It started because hospitals started to have more than one system within their walls, and they had to connect those systems. And if we fast forward to the current time, someone recently observed that the average hospital in the US has over 80 IT systems within its walls. And with the consolidation of hospitals, many systems now have multiple hospitals, but they still need to connect all those systems to one another. Now, we also know that there's more and more data that's outside of hospitals. Pharmacies have data, payers have data, laboratories have data, mobile devices have data, genomic sequencing labs have data, home devices have data. And now the meaning of interoperability has changed. Interoperability really means being able to be in one place and see all the data in those multiple systems for a patient or a population in real time. And not only is data in more places, but there is a lot more data. Dr. William Stead at Vanderbilt University wrote an article a few years ago where he estimated the number of facts that exist per complex decision in healthcare. His estimate is that in 1980, there were about 10 facts per decision. And in 2020, there are about 1,000 facts per decision, and it continues to increase exponentially. And the problem is that the average human can handle only about 5 facts in making a decision. I like to think I can do 6 or 7, but obviously I was behind in 1980, and now, like everyone else, I'm hopelessly behind. So it was with that recognition of the changes that were going on that the standards organization Health Level 7 convened a task force about 10 years ago and asked them the question, what if we created a new standard from scratch? What would it look like? The HL7 version 2 standard was approaching 30 years old and obviously did not meet the needs. CDA was over 10 years old and was not meeting the evolving needs either. And HL7 version 3 had been so complex that it had not been widely implemented. So the task force looked at the environmental data, at the data environment, and that realized that data was going from offline to online. Around the globe, there were data transparency initiatives going on, and data had become a mixture of narrative and coded data. And a gentleman from Australia, Graham Grieve, came forward with a proposal that we now call Fast Healthcare Interoperability Resources, or FHIR. So to explain what FHIR is, it is in its essence a representational state API. It is a specification for how one system asks another system for data and what it gets back in return. And my analogy for this that most can understand is travel websites. If you go to your favorite travel website and say you want to go from Boston to New York on November 15th, you quickly see a list of flights from different airlines. That's not because your favorite travel website has downloaded all the airline schedules. It's because the airlines have agreed on how to represent the data in an airline flight, how to ask for it, and what you get back in return. And FHIR is the same thing for healthcare. It is the same technology, and it is the agreement on the meaning of the data in healthcare. And of course, that's where it gets a lot more complicated, because healthcare is more complex than air travel. So there are a few concepts that you need to understand FHIR. The first is FHIR resources, and that's resources as in URL. Remember, that stands for Uniform Resource Locator. So FHIR resources have a known location on a server somewhere. It might be your server or a server on the internet. FHIR resources have a defined meaning. That's the FHIR specification. And FHIR resources are discrete data concepts like a patient, a family history, a document, a medication, a list. And FHIR uses the same resource, whether it's a list of patients a practitioner has in the hospital or a list of medications. And the care plan resource, which is in fact not a care plan document, but a connector for all the pieces of data that make up an individual's care plan. The next important concept to understand in FHIR is FHIR profiles. FHIR profiles are built for specific use cases, and they consist of all the resources that are needed for that use case, all the value sets that define the data in that use case, and FHIR extensions. And I'll come back in a few moments to exactly what a FHIR extension is. But importantly, interoperability does not come from just using FHIR. Interoperability comes from using shared FHIR profiles, from using the same profile. Another implication of this is that FHIR can be used in 4 different interoperability paradigms. FHIR can be, data expressed as FHIR can be used in messages to send a message to another system. It can be used in documents, similar to a CDA document, where the data in the document is represented by FHIR resources. As we've already mentioned, it can be a REST API, or FHIR can be used in services like decision support services. And FHIR, by its nature, is machine readable and can be consumed by those services. So suppose we had a laboratory result represented as FHIR data, and we got that laboratory result from a REST API. We could then take that laboratory result as FHIR data and put it in a message or put it in a document without transforming it, or we could use that, send that laboratory result to a decision support service that would consume it and could use the data in computing a decision. So no other existing healthcare data standard has that capability of working without transformation across interoperability paradigms. So we say that true interoperability comes from exchanging information, and we mean the same thing. But importantly, not just we humans mean the same thing, but the computer systems that are exchanging the information have to mean the same thing. So let me give you an analogy for what that implies. Suppose 2 individuals had never seen this animal before, and one of them says it's a white horse with black stripes, and the other one says it's a black horse with white stripes. Well, even 2 children would quickly understand they're talking about the same thing, but to a computer system, it's not the same thing. Computers have to have a very specific definition of a data concept to exchange that concept with another system and mean the same thing. So those descriptions, definitions of a data concept for a computer system are called clinical information models. They are all the rules that apply to that data concept, the relationships between data elements in that data concept, and the vocabulary or terminology bindings that are needed to describe that data concept. So, have we used models before? Well, there have been modelers from the beginning, and we use models, but I don't think we thought of them in that sense. So consider a document that's a history and physical for a patient. Suppose we printed out that document, took a pair of scissors, and cut the document into data elements. Now we pick up one of those pieces of paper and it says diabetes type 2. Well, we know what that is, but we don't know whether that was a problem on the patient's problem list, whether it was a problem the patient had in the past before they had weight loss surgery, or whether it was a problem their mother had and it was actually in the family history. So in FHIR profiles have to create those relationships between the data elements in that particular use case or data concept. Let me give you an example from a 20,000 foot level of what a FHIR profile might be. So we'll consider a FHIR profile for a procedure. And that procedure might be a laboratory test. It might be a imaging procedure, or it might be a surgical procedure, but all procedures have some things in common. One is there's the name of the procedure, which would be the FHIR procedure resource. There's a patient that would be the FHIR patient resource, the person on whom the procedure is performed, a practitioner resource, who is the individual performing the procedure. There is an encounter in which the procedure took place. There's the FHIR condition resource, which is the reason the procedure was performed. And for most procedures, there's a diagnostic report that is the results of that procedure. So I said that this is the 20,000 foot view, but obviously those details of that profile have to exist. And to specify those details, there are several concepts in FHIR that are important. The first is terminology binding or vocabulary binding. That's when we create a value set for a specific element in a profile that is the values that that element must have in an implementation. So those values come from one or more code systems, and they are referenced as a URL that's stored on a terminology server. And terminology servers are part of the architecture of FHIR that allow implementations to share those FHIR value sets and code systems across organizations or even across regions by placing them on a FHIR terminology server and accessing them there. So there's no need to upload code tables to each implementation. Each implementation simply reaches out to that FHIR terminology server. The next concept that I said I was going to come back to is FHIR extensions. So part of the design principles of FHIR to make FHIR more implementable and less complex was to represent in FHIR only the data that is in 80% of existing systems. It's a rule of thumb, so it's not an exact measure, but data that is in most systems is what's part of the FHIR specification. But obviously, in any use case, you might have data that's in the other 20%, and that is what is represented by FHIR extensions. And FHIR extensions extend a particular FHIR resource. Extensions do not stand on their own. So as an example, suppose you were a facility that was involved in medical tourism. Patients from different countries come for healthcare at your facility. Well, you need to know their nationality, but nationality is not part of the FHIR patient resource. So you would create an extension for the patient resource that is the patient's nationality. So in your implementation, your FHIR profile would include nationality. Now we're coming to the end of the FHIR story, and appropriately at the end of the FHIR story is FHIR implementation guides, the essence of how we create interoperability between systems and between applications in FHIR. So the implementation guide is a FHIR resource, and it is all the rules for a specific use case. It includes documentation that's human readable and examples of what is done with this implementation guide. And importantly, the HL7 organization has created a tool that will publish an implementation guide and make it available as a URL so that the same URL can be used across many implementations for that particular implementation guide. And very importantly, those implementation guides are machine readable so that you can validate an implementation after it is completed using that machine readability of the implementation guide. So now you've heard the story of FHIR and how it was created to be a data standard to meet the interoperability needs of the future. And I think those needs will continue to evolve. FHIR will continue to evolve. So I thank you for your time today.